Hello students, today's video is on factoring to solve polynomials. The steps that you're going to follow is you're still going to factor the polynomial completely. We're just adding on another step where you're going to set each of the factors equal to 0. So you're going to set all linear factors equal to 0 and solve for x in every linear factor. If you have a quadratic factor that is missing a bx term, the easiest way to solve it is to set equal to 0 and solve for x. Don't forget to add the plus or minus when you are taking the square root. So let's look at a couple of examples. We have y to the third minus 5y squared plus 6y minus 30 equals 0. And so when you see that equals 0 there, that's kind of a clue that you're going to be solving. You're solving for the y values. But the first thing that you need to do is you need to factor. So we don't have a GCF, and there's 4 terms, so we're going to group our first 2 and group our last 2. In the first 2, I can factor out a y squared, and then when I divide by y squared, I have y minus 5 left. In the second group, I can divide out a 6, and I'll have y minus 5 left. So we can see that our parentheses match, so that's our first factor, y minus 5. Our second factor is y squared plus 6. Now, I do have one linear term, so I'm going to go ahead and set that equal to 0. So y minus 5 equals 0, and I would solve it. So you'd have to add 5 to both sides. So one of your solutions is y equals 5. Now, on the squared factor, so the quadratic, it's not a difference of squares because there's not a minus there. And so we would want to go ahead and set that equal to 0 because remember, if we're missing our bx term, if there's not a bx, or in this case by, then you would go ahead and set it equal to 0 and you'll be able to take the square root. So you'll solve by square root. So y squared plus 6 equals 0. If I subtract 6 on the other side, y squared equals negative 6. And then I would take the square root of both sides. And remember, when you have a square root of a negative number, you're going to have to put, that's going to represent I, because remember, I is equal to the square root of negative 1. So the square root of that negative comes out as an I. And then you have the square root of 6, which does not simplify, so you would just leave it like that. And then don't forget to put your plus or minus out front. So your actually 3 solutions. You have positive I square root 6 and negative I square root 6, and you have it equal to 5. So those are your solutions. All right, let's look at this next example. We have x to the third plus x squared minus 12x equals 0. It does have a GCF of x, so let's go ahead and factor that out. So we'll have x squared plus x minus 12 equals 0. We do have our quadratic factor, and so we want to go ahead and see if that factor is using our AC chart. So 1 times negative 12 is negative 12. And we're looking for factors of negative 12 that add up to a positive 1. So we'd have positive 4 and negative 3. That works. And since our a value is 1, then those numbers represent our factors. So we're going to have x, and then our factors are going to come from right here. You're going to have x plus 4 and x minus 3. And we have them all equal to 0. Since those are all linear terms, let's go ahead and set them all equal to 0. So you have your x equals 0, and that's already solved, so that's one of your solutions. Then you're going to have x plus 4 equals 0. So you're going to have to subtract 4. So x equals negative 4. That's another solution. And then x minus 3 equals 0. Add 3 to both sides. So your solution there is x equals 3. So there's your 3 solutions. All right, so what happens if you have a quadratic and it has all 3 terms, but you can't find any factors? Remember that you can use the quadratic formula. And actually, this works on any quadratic. Even if it can factor, you can use the quadratic formula and you'll find out what your solutions are. They would be whole numbers. So honestly, if you don't like factoring and you have a quadratic left over and you want to just use your quadratic formula all the time, then you can do that. Okay, so let's recall what the quadratic formula is, where you're going to substitute a, b, and c into the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's go ahead and look at this first example and let's go ahead and factor it. So looking at x to the third minus 8x squared minus 4x plus 32. I can't divide out a GCF, but there are 4 terms, so I'm going to go ahead and group them. And so in this first group, we have x squared times x minus 8. And then in this last one, we have to factor out a negative 4, and we would be left with x minus 8 as well. So our factors are x minus 8, and then x squared minus 4. Now, x minus 8 is linear, so it's done. But x squared minus 4, this is a difference of squares. And so remember, we can write this as x squared minus 2 squared. And the difference of squares is where you'll take that a plus b and then a minus b. So you'll have x plus 2 and x minus 2 equals 0. Then you would want to set each of them equal to 0. So here we would add 8, so x would be equal to 8. Here, when we set this equal to 0, we would subtract 2, so that would be equal to negative 2. And here we would add 2, and so that would be equal to positive 2. So our solutions are x equals 8, negative 2, and positive 2. All right, let's look at this next example. We have n to the fourth plus 5n to the third plus 8n plus 40. And so we can group. There's not a GCF, so I'm going to group my first 2 and group my last 2. So here I've got n to the third that can divide out. And that would be n plus 5. Here I could divide out an 8. So that would be n plus 5 as well. So my factors are n plus 5 and n to the third plus 8. Okay, now the n plus 5 is linear, so that's as far as you can go. And then the n to the third plus 8, that's going to be a sum of cubes, because we can write that as n cubed and 2 cubed. So let's bring down our n plus 5, and you might want to look back at your formula for sum and difference of cubes. You're going to take the a plus the b, so n plus 2, and then you're going to have a squared, which would be n squared. And then you're going to have a minus a times b, so that'd be 2n. And then you're going to have b squared, which is 2 squared, which is 4. Okay, now, this is all well and good for the first 2, right? We would set those equal to 0. We'd get n equals negative 5. We would set this one equal to 0, and we'd get n equals negative 2. But when we set this quadratic equal to 0, I can't solve it and I can't factor it any further, so you would use the quadratic formula. So the quadratic formula says this: take the opposite of b, so that's going to be 2, plus or minus the square root of b squared, so that would be negative 2 squared, which is 4, and then minus 4 times your a value, 1, times c, which is 4. Then you would divide by 2 times a, so 2 times 1. So let's go ahead and simplify that. So that would be 2 plus or minus the square root of, that would be 4 minus 16, which is going to be a negative 12, over 2. And you still want to simplify that radical. So let me write that, what that would be right here. You'd have 2 plus or minus. Now, the negative, square root of a negative is going to come out as an I, but 12 breaks down to be 4 times 3. And the square root of 4 is 2, and then you would have the square root of 3. So this would actually be 2i square root 3 all over 2. And then the last thing that you can do is, if you can divide something out of all 3 of these numbers, you would, and each of these numbers would divide by 2. So our final n is equal to 1 plus or minus I square root 3. So these are all of your answers. So it becomes pretty cumbersome, but you'll just have to work through it. All right, this last example, 2n to the third minus 54 equals 0. Well, both of these are divisible by 2, so let's divide that out. You'd have n to the third minus 27 equals 0. When you have something to the third power, be thinking about your sum and difference of cubes. So n to the third can just be written as n to the third. 27 can be written as 3 to the third. And so this is our a and our b. So we're going to have 2 times. Your difference of cubes formula starts with a minus b. So n minus 3. Then you'll have your a squared, so n squared, plus a times b, 3n, and then plus your b squared. So that would be 3 squared, which is 9. Okay, all of this is equal to 0. So we're going to need to use our quadratic formula on this part right here. Now I can see already that if I set this equal to 0, that would just give me an n value of 3. If I set 2 equal to 0, there's not a variable there, so this doesn't matter. Okay, so my one solution is 3. But now I'm going to have to use my quadratic formula. So I'm going to do the opposite of b, which is negative 3, plus or minus the square root of b squared, 3 squared, which is 9, minus 4 times 1 times c, all over 2 times a, 2 times 1. So let's go ahead and simplify that. That's n equals negative 3 plus or minus the square root of 9 minus 36, all over 2. So let's keep going. N equals negative 3 plus or minus the square root of 9 minus 36 would be negative 27, all over 2. Okay, so this comes out as an I, so I'm going to have n equals negative 3 plus or minus, definitely have an I on the outside. And then when I split up 27, 27 can break down to be 9 and 3. When you take the square root of 9, you get 3, and when you take the square root of 3, it just stays as that. So this 3 will come to the outside, and this square root of 3 will stay right here. And we're going to divide all of that by 2. None of those can simplify further, so this is one of our solutions, and this is our other solution. And actually, I should say this is two of our solutions because it's -3 plus and -3 minus. And so those are your answers. All right, so as you can see, this can get a little challenging, but just remember to use your quadratic formula if you have a quadratic left, and that will help you a lot. And just keep working through it. Don't push through it. Let me know if you have any questions.